Suppose we want to evaluate the integral of 3x dx over x squared minus x minus 2. It's not obvious how to go about evaluate the given integral. However, if we can rewrite the integral into some addition of rational expression of the form a over px to the n, then we can easily evaluate this integral based on the fact that we know we can evaluate this type of integral where the integral of 1 over x dx is equal to ln of x plus c. So these are the type that we can do, or we can have the type where we have dx over x squared plus a squared, and this is the inverse tangent. Okay, so we want to rewrite the integrand into something that we know how to do the integral of. So let's take a look at the first example, integrating the integral of the form p of x over q of x, where the degree of p of x is greater than the degree of q of x. And I want to change this a little bit. There's a typo here. We should have the 2x cubed minus 2x squared plus 1 divided by x minus 1 dx. Now, when we have the degree of the numerator is greater than the degree of the denominator, one thing we can do is to divide, do the long division of polynomial. So we take a look to see how many times does x minus 1 go into 2x cubed minus 2x squared plus 0x plus 1. How many times x minus 1 go into that? So 2x cubed divided by x minus 1. Here we get 2x squared, multiply it back, 2x cubed minus 2x squared, subtract, and this gets 0. We bring this leftover down, 0x plus 1. I then can rewrite this rational expression, 2x cubed minus 2x squared plus 1 divided by x minus 1 is the same as saying 2x squared plus 1 divided by x minus 1. With that in mind, I can rewrite the integral 2x cubed minus 2x squared plus 1 divided by x minus 1 dx as the integral of 2x squared dx plus the integral of 1 over x minus 1 dx. So this is 2/3 x to the third plus ln of x minus 1 plus a constant. So that is the case when we have the degree of the numerator greater than the degree of denominator. Okay, so again, we will do the long division, and we use the integration technique that we have learned before to separate the integral and go from there. Now, what happens if we have a proper fraction? Let x minus a be a linear factor of q of x. Suppose that x minus a to the m is the highest power of x minus r that divide qx. Then to this factor, assign the sum of the partial fraction as follows. a1 over x minus r plus a1 over x minus r squared plus a to the m divided by x minus r to the m. Note that the exponent is start increasing at the denominator where x minus r is the linear factor. If the factor that we have in the denominator is in terms of x squared, and that is the irreducible factor of q of x, then look at the numerator. We have bx1 plus c1. This should say b1x. So, and the next one is b2x plus c2, so on and so forth. So we would rewrite this. We would rewrite the rational in terms of a smaller rational expression so that we can again take the integration. Okay, and then we will go ahead and we use the least common denominator. We will do all the things that we should be doing to get the same denominator for adding and subtracting fraction, and then we'll do matching with a variable. So let's see how this actually work out. So for example, in the next case, we have the integral of 5x minus 7 divided by x squared minus 3x plus 2. And we will start by rewriting the rational expression as smaller term. Our first factor denominator, so this is x minus 2 times x minus 1, 5x minus 7. So note that we have the linear factor, so these are the linear factor in the denominator. Okay. So I can rewrite my partial fraction at a divided by x minus 2 plus b divided by x minus 1. So let's go ahead and add these two fractions together. Note that the least common denominator in this case is x minus 2 times x minus 1. So then I have a times x minus 1 plus b times x minus 2 divided by x minus 2 times x minus 1. Let's go ahead and multiply the numerator and combine like term. So ax minus a plus bx minus 2b divided by the denominator. We will group the term with x together. So then I have a plus b times x plus negative a minus 2b divided by x minus 2 times x minus 1. So note that here, if this has to equal to the original rational expression, would mean that a plus b have to equal 5 and negative a minus 2b have to equal to negative 7. So I can go ahead and set up this system of equation. So this means a plus b then equal 5, negative a minus 2b equal negative 7, and I will solve the system of equation. I'll do that by elimination. I'll go ahead and add the two equations together. So here I get negative b equal negative 2. This means b is equal to 2 and a equal to 3. Okay. Now when I do that, I can then rewrite the integral. So then the integral of 5x minus 7 divided by x squared minus 3x plus 2 dx is now equal to the integral of 3 dx divided by x minus 2 plus the integral of 2 dx divided by x minus 1. So this equals 3 ln of x minus 2 plus 2 ln of x minus 1 plus the constant c. Let's take a look at the next problem where we have an exponent in the denominator and 2x minus 1 is a linear term. I then will rewrite this polynomial as a over 2x minus 1 plus b over 2x minus 1 square plus c over x minus 1. Okay, so the next thing I do is I'm only concerned about what the numerator would look like, right? Because we only actually working in matching the variable in the numerator. We know that the least common denominator in this case is 2x minus 1 squared times x minus 1. Which means we have to multiply the first factor, the first term, that would a times 2x minus 1 times x minus 1 plus b times x minus 1 and plus c times 2x minus 1 squared. So let's go ahead and multiply everything out and combine like term. Now we will group everything that with the x squared together, everything with x together, and everything as of the constant term together. So then we get, for the x squared term, we get 0x squared, and that equal to 2a plus 4c. For the x term, we get negative 3a plus b minus 4c. And for the constant term, we get negative 2 equal a minus b plus c. We will solve the system of equation for a, b, and c, and we get a equal to b equal 3 and c equal to negative 1. I can then rewrite my integral as 2 over 2x minus 1 dx plus 3 over 2x minus 1 square dx plus negative 1 over x minus 1 dx. So note that here, this term in the middle, we have the integral of 3 over 2x minus 1 squared dx. We solve that integral by u substitution. Let u equal 2x minus 1, du equal 2 dx. Then this integral in the middle becomes 6 du divided by u squared. So that is 6 times u to the negative 2 du. So plus the integral, and the last integral is equal to negative ln of x minus 1 plus c. The integral in front is 2 ln of 2x minus 1. Is it right? So let's start with do a u substitution. If we don't remember, we can let u equal 2x minus 1, right? Then du equal to 2 dx. So this integral become 4 dx. So du equal 2 dx. So that du over u, right? So this is just again ln of u. So that is ln of 2x minus 1 Let's fix the integral in the middle. So we get 3dx equal to 3dx and du equal to 2dx. This meant that what 3dx equal to 3 over 2 du. Okay. So then this integral here in between is 3 over 2 du over u squared. Okay, and that become 2 over 3 times negative 1 times 1 over u, and that is 3 over 2 or minus 3 over 2 times 2 times 1 over 2x minus 1, and the last integral is just negative ln of x minus 1 plus c.